So this is Dr. Krause. I'm going to do a quick video on sign conventions and rotation matrices. The issue kind of comes down to this, that what we define as positive theta 2 for rotation means we start at x1 and rotate to x2, which might seem like it is the opposite of what we mean by R12 that maps from frame 2 or rotates from frame 2 back to frame 1. So I want to talk about this and just make this as clear as I possibly can. So when we talk about a positive rotation, for example, a positive theta 2, that means a rotation about Z2, which would be the same as Z1. Since we're rotating about them, they'd be the same. But initially, the frames are aligned. So when we go to talk about what a positive rotation means, I mean initially, x1 hat and x2 hat and y1 hat and y2 hat would be all on top of each other. And then when we do our positive theta 2 rotation, we're defining positive theta 2 in a right-hand sense. So Z1 and Z2 are both out of the page. And like I said, we're rotating from x1 to x2, which might seem the opposite of what the rotation matrix does. So a positive rotation, a positive theta 2, is in the right-hand sense from x1 to x2 positive. So we start with frames 1 and frames 2 aligned, and we rotate from frame 1 to frame 2. Again, these are sign conventions that I did not make up that seem like they conflict from each other. So we're rotating from frame 1 to frame 2. So theta 2 is positive as I rotate from x1 to x2 in the right-hand sense about Z2. But when we talk about our rotation matrix as it's defined in nearly all robotics text that I've ever seen, we're doing this. We're taking a vector expressed in frame 2 and using the rotation matrix to rotate it back to frame 1. So this seems like the opposite sign convention of this, and that's just a convention, and it's admittedly a little weird, but it is what it is. Now, knowing that, when we talk about x2 hat, if we know what this rotation matrix does, then we're trying to find x2 hat's components along x1 hat and along y1 hat, and both of those are positive in frame 1. We know that this is sine theta 2, and we know that this is cosine theta 2. And those represent the mapping of x2 hat back to frame 1, and they're both positive. So I know that the first column of R12 has to contain all positive numbers, and specifically cosine theta 2 positive sine theta 2 0 is the first column. Now I haven't yet talked about and won't talk about in this video what are the next two columns, but this is x2 hat, good golly, that's bad, expressed in frame 1. So rotation matrix takes a vector from frame 2 and transforms it back to frame 1, but when we talk about how to get theta 2 positive, we're starting with x1 and x2 aligned, and we're rotating from x1 to x2. So those two things probably seem like they're in conflict with one another. That is just the convention that essentially all engineering robotics textbooks use that I'm aware of.